If you can ever see the original version of Godzilla, the opening scene are these fishermen sitting idly on their deck when they see a flash and explosion and then they're knocked to the ground. That was a protest movie in response to our nuclear testing in Bikini in the Marshall Islands. And Godzilla represented that frustration, that idea of this horrible force that's been released that we really need to contain. Sound check. I'm Ken Buesseler, and I'm a scientist here at the Woods Hole Oceanographic Institution. My specialty, my interest is really radioactivity. It's a bit of like forensics, where did this radiation come from? How did it get there? And I go around the ocean. I've been on ships more than 2 years of my life, going to different places to find samples that tell me about the ocean there, about the seafloor, about the biology, or in the case of Fukushima, about contamination. Well, March 11, 2011 is the date of the earthquake and then the horrible tsunami that caused most of the damage on land in Japan. So we're talking about a wall of water coming along different parts of the Japanese coastline that brought with it destruction of hundreds of thousands of homes, loss of life, 17,000 people missing or dead. And then in the case of Fukushima Daiichi, a nuclear power plant, loss of power. When you don't have power to run the pumps to bring in the cooling water, it gets hotter and hotter to the point where things evaporate. You create things like hydrogen gas, so things that are explosive, and that's what we saw a couple days later. All of that radioactivity, more than 90%, 80 to 90%, went into the ocean. So Fukushima is by far the largest unintentional source of radioactivity to the ocean. It's unprecedented that we have. You think about nuclear power plants, there's over 400 in the world. Most of those either drain into the ocean or actually on the coastline. With climate change, those coastally situated nuclear power plants are in harm's way. You need cooling water. It has to be a certain temperature or colder to cool down the reactor. So between sea level rise and warmer oceans, you really have to redesign how you think about operating these power plants safely. Things will get in the ocean if there is an accident at those sites, and a lot of what we're trying to get at is some of the basic research really of how quickly, how fast those move, how quickly they get into the organisms, the marine life, the seafood that might be taken from those areas and buried on the seafloor. The key was getting there. Sort of like a crime scene. That may sound pretty dramatic, but really the sooner you get there, the more you learn. We were given the green light to go find and charter a ship, get to Japan. We were there 6 weeks later with a boat full of research equipment, a team of international scientists, permission from Japan to take samples, but not yet from the US for some of the areas we wanted to go to. So we even set sail without all of our permissions in place. There were a lot of reports about high levels, low levels in different places, different beaches, and we just needed to ground truth that. So we started to sample beaches, rivers, any place we could get a sample, and lo and behold, the beaches in Japan are as big a source as the reactor itself or the rivers in terms of the isotopes of cesium. The highest levels were in the beach sands, in the water contained right below your feet. It was a surprise to us. I think that shows another reason why you need basic research still going on, right? So now next time something like this happens, we'll be at those beaches. As we were going to Japan repeatedly after 2011, we heard about a ship going to the Marshall Islands. After World War II, the US tested a lot of our nuclear weapons, the bigger ones, in these remote islands in Bikini and Eniwetok. We asked people to leave, and then we took their islands and turned them into basically a pockmarked site full of craters where we shot off over 60 nuclear weapons. The nuclear testing produced these mushroom clouds that you've seen that creates what we call global fallout, and that's everywhere we go. Every bit of dust, food, air you breathe has some trace of those early testing years. People were surprised in a way at the level of radiation that was now being spread, not just locally, but globally. The Marshall Islands is relevant to Fukushima. This is where we can actually see now, decades later, the fate of the same isotopes that are being released in Japan. We had the fortunate chance to go back and ask some of the same questions, what is it like after not just a few years, but after decades? And would those sediments, would those craters still be sources of radioactivity? And in fact, they are. That's why I'm pessimistic that Japan will ever not be a source. Radiation readings here are no higher than they were on the beaches, about 20 counts per minute, which you might think is surprising as one of the largest waste dump sites on the Marshall Islands. So an atomic explosion occurred here, and then they filled it in with debris and put this concrete dome on top. We left behind not just these visible scars, but a huge amount of radioisotopes still buried in the sediments in those lagoons that's constantly leaking out. These samples are unique and very helpful in terms of addressing some real serious concerns that remain on these islands as a legacy of the atmospheric testing that the U.S. did here. A lot of people ask about radioactivity and when should they be concerned about the levels in the ocean. The plume that looks kind of scary, right, on a map, an animation of this blob coming across the Pacific, but in fact, those levels are quite low. Lower than things we commonly choose to do, like a dental x-ray. Swimming every day off California today gives you additional risk of cancer that's 1,000 times less than going to the dentist getting one x-ray. So that's part of our reason for doing these types of studies, to see, when are we in harm's way. When you don't know the difference between a little bit and a lot, you can get concerned about even the lowest levels. And I think that's really what happens in the public. They hear cesium in the ocean, we shouldn't tolerate it, we shouldn't allow it, but it's already there. It's around us. That's why we call this our radioactive ocean or our radioactive world. There's still a lot to be learned about different isotopes and the behavior in the environment. We still need to have people making measurements, learning things. All of our federal agencies have kind of stepped back. Department of Energy, they do study nuclear materials on land, groundwater, but when they get in the ocean, that's salty, that's not their job. You go to the EPA and they say, well, we do drinking water, we do the air we breathe, but we don't do the oceans. Maybe talk to the Nuclear Regulatory Commission. So we got bounced around. There should be a responsible federal agency that has programs. A very simple case was, how long would it take for the water that's contaminated to get from Japan to the US coast? We went to crowdfunding. We started a website, Our Radioactive Ocean, and said, if you want to know the level of cesium at your beach, we'll send you a container and send it back to us. We went from a situation where there was no data, no results along the West Coast that we're tracking, to a point now where there are hundreds of data points up and down that coastline. So it's not rocket science, it's ocean science. It takes a few people on a boat with certain skills and some specialized tools, but it's certainly, I think, an obligation that we have as a country, as a world that operates nuclear reactors, has nuclear-powered vessels, has a legacy of burying nuclear waste near or below the ocean. For me, as a kid who watched those scary, crazy movies on Saturday morning, the King Kong, Godzilla movies, I had no idea that they were based on this idea that we've released a force that we can't control.